right, let's get started. Okay, so PS7's due tomorrow, Friday with the late date. PSA will come out end of the week, and we're off and rolling until Thanksgiving. Any questions or problems? PS7 or anything else? Yes.
Like if you wanna test that your constructor is like for the cache list, it's like initializing all those values correctly, but they're private fields. Is it okay to write new methods just to get those? Like
Okay.
methods?
So that's an important question, so I'll repeat it so everybody can hear it. So you're implementing, say, the cache list class, and among other things, it's creating a list of caches, and you'd like to write a test to find out whether that list was created correctly, but it's private, so you can't write a test that accesses it. And he was asking, can you create other methods that essentially expose that list so you can write tests against it? And the answer is no, you shouldn't do that. How do you test a class like that? How do you make sure that the constructor worked?
I mean, what do you just get one of the things from the list, and then your constructor, you can infer that your constructor worked?
Okay, so say it again.
Like if you could just retrieve one of the elements stored in the list, and then you could like infer that your constructor
Okay.
on your list worked.
So you're saying you could retrieve one of the elements from the list, but you got to get at the list to do that. Or maybe you're talking about, what I have in mind is the way you test it is use a select method. So typically in a class with instance methods and constructors, you don't test the methods individually. You can't. You can't test a single method. You got to at least call the constructor to create an object to test. And you really can't test the constructor in isolation. You just got to see that after you construct something, create an object, do the methods work like they're supposed to?
But you have to pass it like a constraint or something to that select method, don't you? Don't you have to set one of the constraints? I want to test
Okay.
the initial constraints.
So he's talking about, he's asking, don't you have to set constraints? No, you can create an object and immediately call select on it. You don't have to set constraints first.
How would I test then that the initial title constraint is the empty string, just because the way that the select method works?
Okay, how would you test that the initial title constraint is empty? You create the object with 5 caches in it,
Yeah.
or whatever. You call the select method right away. Make sure you get back a list of 5, those 5 caches as the answer.
Okay.
Okay? So you can't check these things individually. You have to test them in combination. The only thing you can test individually is the behavior of the constructor when it has to throw an exception. You can do the exceptional test of the constructor without involving any methods. But any other test involves at least the constructor and one other method. Make sure that things go together right. Yeah?
And if you want to make sure that your constructor throws it specifies that you need to have an IO exception and a legal argument exception, do we just overload the constructor so that it can throw 2 different exception types?
Okay, so he's asking about how a constructor sometimes throws an IO exception or can throw a legal argument exception. How do you deal with that? You don't create 2 constructors. You can have multiple constructors, but we don't need them in this case. The truth is that in your cache list constructor, you don't have to ever put the code throw IO exception. That's just there, in case the scanner throws an IO exception as it's doing its work. So you just let it propagate. All you have to worry about is illegal argument exceptions.
But how do I put that in the what's it called, the method, the title of the method or something like that? So if I call that in a main function, it will go and be handled in the main function. How do I specify that the constructor can throw multiple different exceptions?
Well, okay. So the question is, how do you specify that the constructor can throw an illegal argument exception? You don't. You just put it in the Java doc. You don't have to specify anywhere else other than the Java doc that it may terminate by throwing an exception. Okay. I just want to reiterate to you that you can get a perfect score on the parts D, E, and F, even if you don't pass all the tests. And that's deliberate. Right? That's just to give you. I've just noticed this phenomenon that people will get like 10 out of 11 test cases passed or 19 out of 20, and rather than say that's good enough and go to bed, They like spend hours and hours agonizing over that last test case. So, right. So this way, at least you can go to bed having not passing all the test cases and still have a perfect score on those. I keep getting questions if this is deliberate, and yeah, it's not a mistake. I'm just trying something different this time. Any other questions? Yes.
I was just curious if J-Shell can help test constructors at all. Is that just
Okay. Good question. He's asking, can you test, use J-Shell to test? Absolutely. You just go into J-Shell, run J-Shell in your project, and then you would create a new cache. You pass it parameters, and it would store the result in the variable, and you can invoke methods on the variable and experiment with it. I've sort of gotten away from doing that in class, but you're absolutely right. You can definitely do that in J-Shell. Anything else? Yes?
This is about PS7, I think, but will there be a problem set assignment over the week that starts basically?
Okay, so asking about Thanksgiving. So it's kind of weird this year because Thanksgiving, normally there's 2 weeks of classes after Thanksgiving. And this is the first time in my memory there's ever only been one. So the question was, is there an assignment due over Thanksgiving? So you're doing PS7 right now, and then there'll be PS8, 9, and 10. Those are 1 week assignments that will come bang, bang, bang. PS11 then is the last one, and it comes out with, you've got 3 weeks to do it. You can work with a partner if you want to. And so that means that, yes, there's something due, but it's, you've got the week before Thanksgiving, the week of Thanksgiving, the week after Thanksgiving to finish it. There will be a checkpoint. What I found is you don't give 3 week assignments because students put it off to the last week. So you'll have to demonstrate that you've made progress during the week before Thanksgiving. You'll meet with a TA to show that you've made some progress. I'll define what that means. And then you finish it up after Thanksgiving. Okay? So if you think you might be interested in working with a partner on the final assignment, prerequisite is you need to know someone that's in the class. So a good way to do that might be to go to the Women in Computing's event today, which is at 4:30 upstairs in Web 314, MEB 3147. Nothing else, there'll probably be free stuff to eat. So, any other questions? Yes. Hold on, I can't hear for all the talking. So. Okay, everybody, let him be the only one talking. Okay, one more time. Okay, here's the thing. He's asking how do you test for I/O exceptions? It's really difficult. And I don't expect you to. Basically, you might get an I/O exception if you're reading. Well, your scanners are probably reading from streams, and so you're not going to get an I/O exception. If you're reading from a file, an I/O exception would occur if, like your file device, your hard drive crashed or something while you're reading from it. So short of putting a bullet through your hard drive, it's hard to reliably generate an I/O exception. Yeah.
So you don't have to do like anything on the code like throws new I/O.
No, you don't. Right. The specification is basically saying that if the scanner throws an I/O exception, just let it propagate.
Oh.
You don't have to do anything active to make that be happening. Okay, so last time we were in the middle of implementing a map class of our own, so I call it MyMap version 1. And it's a stripped down version of a hash map or a tree map in terms of the methods provided. So there's a method to add a key value pair. There's a method to look up the value associated with a key. There is a method to remove the key value pair from the map. And this is the representation that we came up with. The idea was that we would have 2 array lists of strings. And the first one would contain all the keys that the map knows about. And the Second one would contain, the values array list would contain all the values that that are associated with the keys. And you've got to read both comments to understand what's going on. So the first one says, the keys of this map in no particular order, there are no duplicates in the list. So when you write comments to describe your instance variables, you've got to describe what they're for holding the keys, but also describe any constraints, such as there are no duplicates in the list, because that's important for the implementer to know that they're not supposed to put duplicate keys in the list. Now, you don't have to put in the comment that the list is an array list. You can tell that from the declaration. But any constraint on the value of keys that you can't infer from the declaration, you need to put in the comment. And then the next comment for values, it says the values of this map. So that tells you what it's for. But you got to read on. It says has the same length as the keys list. So that's a constraint. It needs to be the same length as the keys list. And the value associated with the ith key is the ith value, which is probably what you'd expect. But it's good to to confirm that in the comment. And once you know all that, you've got what you need to know in order to do the implementation. So, are any questions I could answer about this? So I always expect you, when you write your classes with instance methods and constructors and such, to put some Java doc for each variable, each instance variable, that gives that explanation. What the variable is for and what constraints there are on it. All right, let's go back and look at the code we were working on. So here's my map, and you remember those are the methods. You see we can construct an empty map like that. Then we can call the put, size, get, and remove methods on it. And here is the start of the actual code. Well, that's not right, because we actually worked on it. So let me try something else. Okay, and I don't have the declarations there because I had them in the slide at the time. I had to put them back in there. So this is what we did. We said, to create an empty map, we created empty arrays and stored them into both keys and values. So initially, keys and values are empty, so they're the same length. There are no keys and no values, that's why they're empty. Then we worked on the put method to put a key into a key value pair, which we have here, into this map. We need to first look up the key in the keys list and find out where it is. So we get the index in that list of where this key is. Like, let's say it's Utah. So we find Utah, let's say at index 2. So if it's at index 2, we're going to be in this bit of code, and we're just going to go to the corresponding index in the values array and change its value. So that's the case where you're changing the value of an existing key. Now, if the key wasn't in the list, we're going to get a -1 back from IndexOff, and we'll be in this case, and we'll add the key to the end of the keys list, and we'll add the value to the end of the values list. Therefore, maintain them both the same length, and such that the key and the value are stored at the same index in their respective lists. So that was our put method, and I think that's as far as we got. So, what questions might you have about this, how this works? Yeah?
So like you didn't specify the data type for your array list. Does that just like the first value or the first thing you store in the array list, does it just assume that all the following things you're going to store are going to be the same data type?
You're talking about right here?
Yeah.
Okay. Well, that's because keys is declared right here. And up here I did say it's an array list of strings. So it was able to figure out what the type of the array list was, what type of thing was in it by looking at the declaration for keys. Same goes with values. All right, let me ask you a question. What would happen if we did this? This is actually a fairly common mistake. Oh, Wouldn't be able to call in private here, so I'll take that out. Okay? What's going to happen if I declare keys and values as being local variables to the constructor? Yes? Okay, they will not be, if you declare them inside the constructor, they're not accessible from any other method, which is not what you want in something like this. So what's going to happen though? So when you call the constructor, you'll create two local variables, contain keys and values, and store them in local variables. What's going to happen when the constructor returns? What's going to happen to those lists? Yeah, they're gone. You know, the local variables go away. And what's going to happen when you then, so now you've got an object, it still contains these two instance variables. We call put, what's going to happen when we try to manipulate values and keys down here? When we constructed, we did not initialize these variables. So we're going to have an object with uninitialized instance variables. What will happen when we call put? Well, it's not a compiler error. You look down here, you won't see anything flagged. We'll be able to run this. Yeah? What would happen?
But an exception.
You get some kind of exception. Probably you'll get a null pointer exception, which basically tells you that the compiler stored null into these variables since you didn't store anything in them. And then when we come down here and try to use them, we try to do null.IndexOff. That's when you get a null pointer exception. And we can see that. We'll just run this. We'll see what happens. So let's run it. I saw some red flash by. Null pointer exception on line 46. So it's right there. We tried to put a key, we tried to look into the keys instance variable, and it's null because the constructor didn't initialize it, because we accidentally declared these things local. Now there is a clue that you've done something wrong. Right? Where's the clue that ought to be the red flag that says, or the yellow flag, that something has gone wrong? Yeah, you look here and you say, oh, the value of the local variable keys is not used. Now, at that point, some people are inclined to go, it's just a warning. I won't worry about it. Program still compiles. But that should tell you two things. First of all, you see the value of the local variable keys is not used. I ought to say, oh, this isn't supposed to be a local variable. That's your first chance to realize it's an error. But you also see that it says it is not used. And you say, well, what do you mean it's not used? It's used down here. Okay? So why is it saying it's not used? Yeah.
Is it because it stores it in the private?
Well, yeah, these are local variables, but nevertheless, we're able to use keys right there. So what's going on? Yeah.
The local variables up there are out of the scope of the put method.
Right. So to what does this keys refer?
That refers to those variables up there. That
Right.
Have them.
So it looks like we're using keys and values down here, but they're different variables.
Yeah.
And if I right-click on this and say go to open declaration, I say open declaration or hit F3, it'll take me up there and show me that's the keys that we're talking about. So that's a mistake you don't want to make. So I don't want to. But let me tell you a related question I get. I've already gotten this several times. I know I'll get it many more times during the semester. And that question is, I've got this value in my constructor. How do I communicate it to the other methods? Like I'm implementing the cache list class, and I've got a local variable that holds the list of all the caches. How do I communicate that to the select method? So what's the answer to that question?
So like make an instance variable.
Right, you need to have instance variables. Instance variables are for representing the state of the object that needs to be shared among the constructor and the methods. All right, now, let me fix this, and I'll show you other mistakes people make, and we will try to understand why it's a problem. What would happen if up here you declared these variables static? Now, this is something I've told you not to do, unless, 99 times out of 100 it's the wrong thing to do, and it's the wrong thing to do in this case. What does it mean to declare those variables right there static? You'll notice that there are absolutely no warnings anywhere in the program, no errors that anything is wrong. If I run the program, I don't know why I printed out null there. I'd have to look at it. But anyway, what's the problem with doing it that way? Oh, it was printed out null because I didn't finish all the methods. That's why. Yeah.
This way, like every time your program makes an instance of the bimap object, they'll all share those two
Okay.
variables, so they'll all have the same value.
Right, so the key thing he said is that all objects will share those two variables. If variable is static, there's one per class. You create 1 million bimap objects, they're all using the same two static variables, which means they'll be interfering with each other. One object, you create 10 objects and you call the put method on one and the put method on the other, they both change the same array. That's no good. So static means one per class. Non-static means one per what? Object. And that's what we want. Instance variables need to be one per object. So don't declare things static just because you can get away with it. Now, in this case, would there be a problem? Look at my main method. Suppose I were to finish implementing my class, but I use static variables instead of instance variables. Would I see a problem? You wouldn't. Why not?
You're only making one object.
Because I only ever make one object. So you can fool yourself. If you only create one object in your tests, you may find out that if you use static variables, that you thought it was right, but it's not. And typically, when I create test cases for assignments like this, I make sure to have test cases that create multiple objects and test them individually to make sure that you're not using static variables. It's an easy thing to figure out. Right? So that's not so good. All right, now, let me show you another mistake people make. People say, oh, you can declare variables like that. So they come down here and they say, oh, I need an index variable. I'll just put it up here. And now there are no warnings, no compiler errors. But it's bad. You could tell me there are two different things that are wrong about doing it this way. Yeah?
Well, first, is it just kind of a waste of memory?
Okay, he said it's a waste of memory, so let's think about that. How could this be a waste of memory to have an instance variable, to declare the variable up there instead of declaring it in the method? Yeah?
Well, that variable will always exist as long as you have it closed, so it won't, when the scope of a method that uses it closes, it won't be unallocated.
Okay. So let me paraphrase. If you declare something as an instance variable, then every object will have an instance of that variable. So an int in Java takes up 4 bytes. So if you only ever create one object, you've wasted 4 bytes. If you create 1 million objects, you've wasted 4 million bytes. So any variables you put up there that aren't really instance variables, that don't need to be there, you're wasting space in every object you create. Because if it's in a local variable, when you call a method that uses local variable, the local variable will be allocated over the stack and it'll be immediately deallocated. So it's not wasting space. So you don't want to bloat your list of instance variables with things that absolutely don't need to be up there. Because it just makes the object bigger. Each object has a larger footprint. And if it's an object that's used frequently, then you've wasted a ton of space. There's another problem with it. Suppose you declared all your local variables as instance variables just because you like seeing them all there. And imagine you've got 2 methods that each use a variable called index. And the one method calls the other as part of its operation. So suddenly this method is using index, and as part of its operation it calls this method over here, which also uses index, and it overwrites the value of this guy's index. So they interfere with each other. Local variables, the nice thing about them being local is this method can't mess with this method's local variables. You make them instance variables, that guarantee is gone. So don't do that. Don't put things up here. Don't be afraid to put things up there if they're necessary. But don't put things that can be, that are really instant. Don't put things that are local variables, make them instance variables. So how can you tell if something needs to be up there? Why do keys and values need to be instance variables? What is it about them? What is it about the key list and the value list that makes you realize, oh yes, those are instance variables, not locals? Okay.
They're part of the representation.
Well,
They serve more to, like, to represent what it is than to serve a specific function in a specific method.
okay. So let me give you, here's a way to think about it. Let me ask you a question. Does a map have keys? Yeah. Does a map have values? Yeah. Does a map have an index? No, you don't talk about a map's index. So those first two, since map consists of keys and values, that suggests those are instance variables. A map doesn't consist of an index, so that doesn't belong. Or another thing is, you face this question of you need to use keys in this constructor, and you also need to use keys in all these methods. So if you need to access the same thing from a bunch of places, it needs to be an instance variable. Okay, so those are just some fundamental mistakes that it's possible to make. All right, there's our put method. Let's do remove. So the idea now is someone says remove this key from the map, and we remove it if it's there, otherwise there's nothing to do. So look at the code for put for inspiration. How would you remove a key value pair from a map, assuming it's there? How would you find out if it's there? Yeah?
You'd have a searching loop, look for that key in the key list.
Okay. You could use a searching loop, or you could use a method to do it for you. So we'll do that. So this is an example. Two methods have a local variable called index. And they have nothing to do with each other. So don't fool yourself into thinking, there's an index in both places. That should be an instance variable. They're just called index because I copied and pasted. It's not like the value actually stored up there matters down here, and vice versa. All right, so now we know if index is greater than or equal to 0, then there's work to be done. If it's less than 0, then the key's not even in there, and so there's nothing to do. But what is it we need to do to remove the key value pair from the lists?
You just set the key value to null at that index?
He said set the key and value to null at that index. The problem with that would be, down here, we're reporting the size of the map as being the number of keys in the map. And actually, we probably ought to put in our comment up here that keys cannot be null. So yeah, that's a reasonable idea, but I don't want to do it that way. So I'm not going to set the key and the value to null. How can we get them out of the list?
Could you create a new list without them?
We could make a list, copy the list into a new list, and without copying, but yeah. Right, there's a remove method. So we say keys.remove, and it takes an index. So we'll give it an index. So that just says remove whatever's at that index of keys. That'll remove the key, and then we'll do the same thing for and that'll do the job. So we just modify those two instance variables, modify the objects they reference so that they no longer contain the key or the value. And now we have, you got to make sure after you do it that your lists are still the same length, that keys correspond to their values. There are no nulls, so we're good. Any questions about that?
How does it behave if you try to remove an index that's not in, beyond the bounds?
if you try to remove an invalid index, it's going to give you an index out of bounds exception. We don't have to worry about this here because we already know that index is good. We computed the index. As long as we check that it's greater than or equal to 0. If we didn't do that check, we'd be vulnerable. Anything else? Okay, here's the last method. It says returns the value to which key maps if I don't know why I said if one exists, if the key exists. Okay, yeah. So anyway, if the key exists, we return the value to which it maps. Otherwise, we return null. So this is going to have, again, the same structure as this method, in that we're going to look up the key and do something depending on what the value of the index is. So what is it that we do if the key exists in the keys map? Yeah, you go to values, you get the thing from that index, and you return it. And what do we do if no key exists with that name? What's it say? It says return null. So we do that. And that completes our implementation. I have some tests here. We can make sure that I passed the test. So that's good. Okay. You know, if you have a little trouble visualizing what's going on, what I suggest you do, set a breakpoint right there in this test case, in this main method rather, and debug it. Just watch what's going on. So let me try again. What the heck it's doing? Okay, so I do that. This is hard for you to see in the back, but here's M. If I expand M out, M is the map I just created. If I expand that out, what am I going to see? Keys and values. And if I expand keys, you know, there's nothing. They're empty, so there's nothing to see. Now I'm going to put Utah 4. So I'm going to step over that, and look what's happened. Keys now have an element Utah and an element 4. And if I highlight keys, it puts the list down there at the bottom, so you can see it's Utah, and the list, the values of values is a list 4. Now I'm going to put, I'll print out the size. That'll be 1. Now I will put Ohio State in, and you'll see that again it changed. Keys now is Utah, Ohio State. The values are 4 and 1. So you can watch these things change. You can step into the methods and watch what's happening as well, but I'm not going to do that. So we'll print out the size. Now we'll get the value of Ohio State. That's 1. Utah's value is 3. Now I'm going to remove Utah. So boom, my list shrunk. Keys just contains Ohio State. Values just contains 1. And if you want to see more, create a couple objects and watch how they change independently. Okay, so that's one way to implement maps. Now, it turns out that this is not the way tree maps are implemented, and it's not the way hash maps are implemented. This is actually a pretty bad way to implement maps because it's slow. And what makes it slow? What's the bottleneck here? What makes where do you think the bulk of the time is spent in the put method?
Finding the index of.
Yeah, that index of is the bottleneck because it has to look through the list looking for something. If it's a long list, it'll take a long time. And so hash maps and tree maps, what they do is they provide a faster way to do that lookup. That's something you'll study in 2420 in depth, but I'm not going to go any further in this class to explain what's going on with that, because I've got other things to talk about. But let's look for a different way to implement MyMap. It's not going to make it any faster. I just want to show you that you can have a completely different internal representation, different instance variables, and it still behaves the same externally. It'll look different when you debug it, but you run through test cases and run your main, it'll look the same. And my proposal is, let's use one list instead of two. How could we get by with a single list? Yeah.
The key would be like the element, and then the value is just the element next to it.
Okay, that's an idea. So what we could do is we could store the keys in the even numbered indexes, 0, 2, 4, 6, 8. We could store the values at 1, 3, 5, 7. And that works in this case because the keys and the values are both strings. So a string array would work. But it wouldn't work if the keys were strings and the values were something else. So I'm looking for a different solution. But yeah?
Could you just make the index what the value would be, and then whatever is assigned to that index would technically be your key?
Okay, so what are you making the index into the list?
Oh, I was just, the index would maybe be the value.
Yeah. So what he described is sort of like a hash table, a hash map. So the way a hash map works, I said I wouldn't do this, but I'll just give you a preview, is you have a function that will turn a string, say, into an int. So it's called a hash function. It gives you a way of converting a string into an int, and then you use the int as an index into a list. But yeah, I don't want to go there either. So what's another way to get by with a single list? So that conversation happening over there on my right is bothering me. Hello? Don't talk, please.
So you're saying like you want a list with two different data types? Is that what you're saying?
No, I want a single list, a list of a list of something. The question is what sort of things should go into the something.
Maybe just like the location of the variables or something like that in memory?
No, not what I have in mind. How can we somehow glue the key and the value together so they're stored together in the list instead of in two separate lists?
Concatenate them?
Well, you could do some trick like take the key and then concatenate it with a comma and then the value, like
Then you can
you
parse whatever you get out.
Ohio State, comma 1. But then if you got some key with a comma in it, you'd be in trouble. Yeah?
Could you make a list of size 2 lists?
Okay, he's suggesting a list of lists. That's getting closer to what I have in mind. So have a list of an array list of array lists, and each element of the outer array list is a list with two elements in it, key and value. Okay, but again, that assumes the key and value are the same type. There's a little cleaner way to do it. Can you think of a way to glue two keys together into a single object, where it's easy to separate out the key and the value? Yeah, create a new class. Just like you can have helper methods, you can have helper classes. So let me show you what I'm talking about. Under map 2, I have pair.java. And this is a helper class. It provides key value pairs. So the class is called pair. It has an instance variable called key, an instance variable called value. The constructor just stores the key and value into the instance variables. And notice what I've done. The instance variables have the same name as the parameters. So down here, key refers to that. This dot key we disambiguate, so it refers to the constructor. I'm sorry, the instance variable. So we can construct a pair out of a key and a value, and then we have a get key method and a get value method that return the key and the value respectively. So what we can do is have a list of what? Pairs. We have a list of pairs, and we use that as our representation. And I wouldn't say it's any better or worse than the other way. It's just an alternative way. It's really not any faster or any slower. It's another way to accomplish the same thing. So let's take a break for a few minutes, and we'll continue along this vein. This is really quick. Yeah, that'd be better. All right, let's get started again. All right, so here I am back in, this is the other MyMap, the second version. And let me make sure it's really what it is. we want to make this thing work just like the other one. So given what I just described, what instance variable do we want? I said we wanted one list. So what would be the type of that list? Array list of, not of strings this time, but of what? Pairs. Because we created a pair class just because we needed one. I don't have to say that, so. Actually, I'm going to change topics completely because I just want to point something out. If you get a new computer, I got mail from someone that got a new computer and then installed Eclipse on it and found that JDK 12 is no longer, it's passe now. They're not supporting it anymore. You can't even get it from them. JDK 13 is a new thing. So that's fine. You can use JDK 13. The only danger is if there are any methods added in version 13 that weren't in version 12, we'll have trouble when you hand in. So, but you'll see that when you try to submit your code. If it doesn't compile because there's some new method, that's going to be the reason. So keep that in mind if you're running version 13. Okay, so there's our. No, I didn't want to even do that. Let me do this. I want to make it private, and I want to do that, and then in my constructor, what do I need to do? Yeah, I need to do what I was doing up there. I need to initialize my variable. So there we go. This semicolon. And so we initialize our one list in the constructor. Now, I'm not going to do all of these. Let's at least do put. What's it going to take to put a key value pair into that map? So if it already maps to something, we replace the key. Otherwise, we add a mapping. So for inspiration, let's just go back to the original MyMap and let's copy this code and then modify it. Save me some typing. So what's going to be different? What do we do differently in the case where we need to change the pair?
You need to create it first, don't you?
Okay, we need to create the pair to put in. I'm going to do that up here. I'm going to call it KVP for key value pair. And I'll say the new pair consists of a key. And so our job is to put that key value pair in the right spot. So let's say that the key does not exist. We're down in this case where the key does not exist. What do we need to do to the pairs?
Add the new pair.
Yeah, we just add this to the end. KVP. What do we do if we know the index where the key is, the index where the pair is, and we need to replace it with a new pair? What do you think? How can we replace that pair?
Same way you just said.
Yeah, we just use pairs.set. And the index is the index, and the KVP is the new value. So we'll replace the existing key value pair with an old one, with the new one. So all that's left is to find the index of that key. And unfortunately, this won't work. Well, it's going to say that it works, but it's not going to find the key as an element. In fact, if we look at this error, it's going to say it's unlikely that the string is what you want to look up, because the list is a list of pairs, and we shouldn't be looking up a string in such a list. So how are we going to find out where we got to find out the index of a pair in this list here that has the given key as its key. Now, how are we going to do that? Yeah?
Do you have a method over in your pair class to get key?
I have a getKey method in the pair class, yeah. I got a get key and a get value.
I guess I was just thinking along the lines that you would use that. I don't know. As I said that, I don't know exactly how to implement it, but
Okay.
you would use that to find it.
So the answer is there are some, using the slightly more advanced techniques we looked at, there's a way to use a method in the list class to find it. But what we're going to do is just write a helper method. Since the method doesn't exist that we need, so we're going to say private int get index. So this is going to be a private instance method, and so it's going to take a key. And let's take some time to write down what it's supposed to do. Returns the first pair that contains the given key. If there is no such pair, actually returns the index of the first pair. If there is no such pair, returns -1. Okay. So we just need some sort of loop. So I'm going to use this enhanced for loop. Okay. This is very commonly missed on the midterm. Gradescope lets me see the questions that cause people the most trouble. And there are a lot of you that didn't know how to write an enhanced for loop when you needed to. There's no need to be afraid of it. What does that say right there? What does that mean? How does the loop work when you write for pair p colon pairs?
For each element in the list of pairs.
Okay, so for each element list of pairs, yeah.
For each pair P, in pairs do something.
Right. So you don't have to worry about telling it how to get the pairs out of the list. It takes care of it for you. Just the first time through the body, P will be the first pair from the list. Next time it'll be the second pair, the third pair, the fourth pair. And I heard a student complain that this kind of for loop was too abstract. And that's right. It's more abstract than a regular for loop, but abstract is good. It's a lot easier to use. You don't have to generate indexes and look things up. You just say, okay, give me every pair in turn. Now, I just realized this is not going to work because I'm going to want to say something down here. If p.getKey equals key, man, they're really pushing content equals. What do I return? So what I'm doing is I'm looking at each pair and seeing if the key contained in the pair is equal to the key I'm interested in. I'm supposed to return the index, but rats, what's the problem? There's no index to return because I'm using this kind of for loop. So, shucks, I'll just go back to this kind. Sometimes you need the index. And then we have to say, so all this stuff I'm having to type is done automatically for you if you use the for each loop, but in this case I needed the index. So what do we return? If we're looking now at each pair in turn in the list, we find the pair we want because it has the right key. What do we return? Yeah, we return I. And then if the loop ends without us having found anything, we return -1. Okay, great. Now, it's giving this yellow underline because it's saying the method is private and it's never used. But we're about to use it, so don't worry about that. So up here, we just have to say we use our helper method to get the index. Now, look at that call to get index. We're telling it, get the index of that key, but we're not giving it the thing to find the index in. We're not giving it a list as a parameter. How do we get away with only passing the key as a parameter and not the list it's supposed to be looking in? How does this work?
Doesn't the get index
Okay. GetIndex right here is an instance method, so it has access to the instance variables. So it just, whatever object put was invoked on, GetIndex is invoked on the same object, and it has access now to the instance variable pairs. Now, let me show you another mistake people make. They say, oh, I need a helper method, and they're so used to writing static, they declare their method as private static int. Now what's gone wrong? Why is pairs suddenly underlined in red? Why would putting static in cause an error and taking it out make the error go away? Yeah?
A non-static method is invoked on an object, whereas a static method is not.
Okay.
So pairs is the object, or...
All right, so pairs, in other words, pairs is anytime you write an instance variable, it's an abbreviation for this.pairs, right? You look for the pairs instance variable in the object on which the method was invoked. But there is no this when you call a static method. So basically, a static method does not have access to the instance variables. And that makes sense, because when you call a static method, it's not called on an object. And so if it were allowed to access an instance variable, the question would become, which instance variable? There are a million objects. Which object are you talking about? Now let's see what quick fixes this offers. If I hover the mouse, it says, cannot make a static reference to the non-static field pairs, and it says one quick fix available, change pairs to static. And this is what lots of students do. They go, oh, great. And they change it to static, and all the red lines go away. But what has this hypothetical student just done?
They made it so like every object is going to share the same.
Right. This is what I talked about at the beginning. Now the instance variable is static, so it's not an instance variable. It's shared. Every map will use the same array list. That's no good. Now I've seen this worse than this. I've seen where the students they'll do this mistake, or a similar one. They'll hover the mouse. It'll suggest making some variable or some method static. They'll say, yeah, and they'll click it, and that will cause another error elsewhere. And it'll say, and the error will say, okay, make this other thing static. And they end up clicking all through their program, and turning all their instance variables and instance methods into static. And finally, the red goes away, and the program doesn't work. So beware of that. You can't blindly click on these hints that Eclipse is going to give you. Think about what's going to happen before you click on it. Okay? So the rest of the methods, like remove, get, and size, are going to be very similar. It's just that where we used, in the original class, where we used the index method for lists, we'll just use the getIndex method on pairs, on pair lists. And the coding will be very much the same. Be a little bit shorter, actually, because we don't have the two separate arrays to muck with.
What was the point of saying static in a method in general? Like, why would you want that?
Okay, he's asking, why would you declare a method static in general? Well, think about the math class. The math class provides a bunch of static methods. What would it mean if they weren't static?
That maybe like math has some sort of fields instance variables.
Right.
That are
So
changing or something.
right. So that would only make sense if there were some instance variables that all these methods need to share, but they're not. You could go through and change the math class so all the methods were non-static, were instance methods. Don't add any instance variables. But now the pain is to use square root method, you'd have to create a math object to invoke it on. It's just easier just to call it directly. So not all methods need to be static. Static methods are for creating new classes, new kinds of, non-static methods. Instance methods are for creating new types of data where the methods and constructors cooperate to update some instance variables. Most of the methods you've written, all the methods you've written, PS 1 through 6, have been static because they were standalone. They didn't depend on each other. Okay? Okay, let me show you another example. So I want to create a rat class. So Java provides ints and doubles, but no fractions. So, if I do 1 divided by 2 with ints, I get 0. And if I do 1 divided by 2, or say 1 divided by 3 with floats, I get round off error, right? Or doubles, I get round off error, 0.33333 to some length, but I lose the trailing 3s. I would like to get the exact answer, which is 1/3. So I want to create a new type of data called rat, which is short for rational, that'll let me create objects like 1/3 and 2/5 and 1/10, and will let me multiply them and add them, subtract them, divide them, compare them, and print them out in their full glory. The entire, you end up with some long denominators and long numerators, but I'd like to see the gory details. So that doesn't exist in Java, so let's make it exist. So let's look at the class. It's called rat. It has a constructor here that the comment says creates the rational number 0. So when you call this constructor with no parameters, the idea is the instance variables, which you haven't decided on, should be set up so that this object behaves like the number 0. If you add it to a different rat object, you should get, it should be an additive identity. So we need one like that. I have another one that you pass it an integer in. Now these are longs. I'll explain why I'm using longs. A long is just a 64-bit integer, so it's harder to get overflow. You get much bigger longs than ints. If you pass the constructor a single long, like 7, it'll create the rational number 7, 7 over 1. And that object should behave like the number 7. If you pass it 2, like n and d, then that's creating the fraction n over d. So one thing you notice is I have 3 constructors, each named rat. That's called overloading. And you can overload constructors. The rule is, though, the parameter lists have to be different. So when you call the constructor, it's clear which one you mean. You can't have 2, for example, you can't have a second rat constructor that takes a single long, because then it would be ambiguous which one you're calling when you try to call one up. So those are our constructors. So I need a main method, I guess, just to because I want to type some code up here. So we should be able to do something like this. Rat R1 equals new rat 5. So that's the number 5. And then I should be able to say rat R2 equals new rat 3, 4. And that should create the rat 3/4. If I say, okay, print out R1, it should print out 5. And what should it print out if I do if I print out R2? It should print out 3/4, 3/4. Okay, so far so good. So we got a way to construct. Unfortunately, we'd like to be able to write rational literals into the program, but we can't. We have to call constructors to create them. So we got rat, we got long. So there's a method called add. And it takes a rat as a parameter. And let's see what it says. Returns the sum of this and r. And then it gives some examples. We do that. We do that. And this was a comment for another purpose, so I'll just make it. Okay? So what it says is that if you have 2 rats, you should be able to add them like that. X dot add of y. So up here, what would we do if we wanted to add R1 and R2? Well, I'm just saying, what do we, to call those methods, you just say R1 dot add R2. And we could store that in R3. So that would be the rat 5 3/4, which is 23/4, right? Okay, so we can add them, and this kind of bugs me because it's asymmetrical. We're used to addition being symmetrical between the 2 parameters, but here one of them is the implicit parameter, the other is the traditional parameter. But that's how you would add 2 things. We also have methods sub that will subtract two rationals, mul and div that multiply and divide two rationals. Let's see, there's sub, there's mul, there's div. There's a compare to method that works like other compare to methods you've seen. So you compare two rats, it returns an int, which is either negative, 0, or positive, depending on whether the first rat is less than, equal to, or bigger than the second rat. And then there's a string, there's a toString method that prints it in lowest terms. So if the numerator is 6 and the denominator is 8, it'll print 3/4. And here is a two-double method. So we might get tired of seeing the full glory, the long numerator and denominator, so we want to convert it to a double. And this is just a helper method, greatest common divisor, that will come in handy later. So that's what I want. I want to have a rat class with those constructors and those methods. And I've spec'd it out. I've got the comments you need. What's the first step? What do we do first? Implementing a class. If someone has taken the trouble to give you the type method stubs, basically to stub out the class for you with JavaDoc. And now your job is to go write the code. What's the first code you think about? The representation. You have to design the representation. So let's design a representation. In other words, what instance variables do we need? If you cut open one of these rat objects, what will we find inside? Probably a numerator and a denominator. So that's good. So let's assume there'll be two instance variables. I'll do num and den, just because that's easier to type. Numerator, denominator. What type of thing should they be? Should they be doubles? Should they be ints? Should they be characters? Should they be lists? Long. Now, you may ask why long. This is the reason why. Ints, once ints get too big, over 2 billion or so, they wrap around to negative numbers, so you get integer overflow. Longs do the same thing, but they have to get much bigger before they overflow. And the numerators and denominators tend to get really long when you compute them exactly. And so using longs instead of ints just puts off that overflow problem longer than using ints does. Otherwise, using longs and ints are exactly the same. We'll make them private, not static. So we could put these two instance variables into our program and start writing code, but you've skipped a very important step. What else do we need to do? Yeah?
What if you don't put private? Just
Okay. What if you don't put private? That's it. I didn't point that out as a mistake people make. What happens if you write a class and you get it working perfectly, and then you go remove private? You make your instance variables public.
People start using it.
Okay, but will you start failing tests right away? No, you won't fail tests. It'll still work just like it did before. You'll lose points in the TAs, so that's a bad thing. But the reason you don't do that is because if you do that and you have lots of users, they'll start accessing, they'll be able, if they have an object, they can access the instance variable directly. And then you're stuck. In the future, you'll have a hard time changing that instance variable because people are used to it being there. So we don't make them public because we want to be free to change them in the future. Yeah?
what if I just say long num without public?
Okay, if you don't say public or private, that's called package protection, which means the variable is accessible from anywhere inside the package that the class is in. So it will be accessible from some other classes, but not every other class. And then there's another one called protected, and that's the story for in a few weeks. All right, so we want them private. What else do we need? It's not enough just to declare your instance variables. What do we need to do? Yeah, we need to think about them. Right, we need to write the JavaDoc for them. We need to explain how do they relate to each other? Is there any constraint? So can you think of, can you store any old number as a numerator and any old long as a numerator, any old long as a denominator? Or are there some values you'd never expect to see? Yeah.
You can't have 0 as the denominator.
Okay, so let's make a list of constraints. So first of all, denominator has to be not equal to 0. That's not a legal rational number. Okay, so we never want to store 0 as a denominator. Okay, so that's one. Can you think of anything else?
You don't have to say that they have to be integers, right? Because they've already said
Yeah, we don't have to say they have to be integers or longs because it says that right here. Let me pose this. Suppose you have the fraction 2/3. So the numerator would be 2, the denominator would be 3, right? What about this one? That's kind of a weird looking fraction. What's a more normal way to write that? As 2/3. So these are really the same rational number. So the question then becomes, do we want to, every time we construct, suppose someone calls the rational number constructor and says the numerator is -2 and the denominator is -3. What should we store in the instance variables? -2 and -3 or 2 and 3? Either way, you could make either way work. But to my taste, I think we should make a rule that we don't have, we don't let both the numerator and the denominator be negative, because we're just not used to thinking that way. Now, what about this? Suppose someone says -2, denominator 3, or numerator 2, denominator -3. Which of those is more pleasing to your eye? Yeah, the first one looks more like something you see in a math book. You never really see it in that form. So I'm going to say that the denominator, I didn't mean to do that. The denominator must be greater than 0. So really, that subsumes that comment right there. So one restriction is the denominator has to be positive. So if you want -3/4, the denominator is 4, the numerator is -3. If you want -3 over -7, we're going to require that the numerator be 3 and the denominator be 7. We never let the denominator be negative. All right, here's another one. What about this one? What would be a more normal way to write that? Is 1/2. So again, we could make it work either way, but if someone asks to create a rat whose numerator is 12 and whose denominator is 24, we need to just store 1/2. And that has the added benefit of keeping the number smaller so overflow won't happen as soon. So I'm going to say that the greatest common divisor of the numerator, the absolute value of the numerator, and the denominator is equal to 1. So the GCD of 12 and 24 would be 12. That's no good. But in other words, I want the fraction to be in lowest terms. Okay? How will 0 be represented?
But not every single fraction can be written like that, though.
Sure, every fraction can be written like that. What would be one that couldn't? So let's look here, 2/3.
5/6.
5/6? What's the greatest common divisor of 5 and 6? What's the largest number that divides into both? It's 1. Okay, what would 0 be?
0 over 1.
Right, you have to be 0 over 1. That's 0 in lowest terms. You wouldn't expect to see 0 over 10. Because they both have a common divisor of 10. So 0 over 1 is the preferred form for that. Okay? And then a number like 5 would have to be stored as 5 over 1. Okay, so we would need to put these constraints here into the comments. And I don't have time to do that. I have time to do very little, but I do have 6 minutes. So I'll add that after class. So back to here, we're going to have is my window key stuck again? So we have private long numerator, private long denominator. So let's write the constructors. It says creates the rational number 0. And remember, implicitly, I've got a comment up there that explains all those constraints I just talked about. So if our user says, all right, create the rational number 0, what do we need to set numerator to? And what do we set denominator to? Right? We decide numerator should be 0, denominator should be not 2, but 1. Okay? Down here, how do we create the rational number n? Okay, it's tempting to say the numerator is n and the denominator is equal to 1. It's not only tempting, it's correct. So, okay? What about down here? Numerator is n, denominator is d. So first we have to check if d is equal to 0, we have to throw a new illegal argument exception. So let's take care of that first. So now we know d is not 0. Okay, so d has to be positive. So here's how we can fix that. We can say if d is less than 0, let's say d equals negative d, n equals negative n. Okay, so what have I just done? If d is 0. I'm sorry. Right. That's what I do if d is 0. What do I do if d is less than 0?
Make the denominator positive now and the negative.
All right. I basically, if you think of it as a fraction, I multiply the top and the bottom by -1. That just flips around the negative sign, so our denominator is always positive. And then I've got to do something like this. Remember, I had a helper method down below called GCD that computes the greatest common divisor. So d equals the GCD hold on. N is what I'm doing first. N equals n divided by the GCD of the absolute value of n and d. So I divide n by the greatest common divisor to put it in lowest terms, and then I do the same thing with d. And I'm done. Well, I'm not done. What did I neglect to do? So let's see. I made sure it wasn't 0. I flipped the signs if necessary. I factored out the greatest common divisor, n and d. What have I forgotten to do? Here's the whole picture. So what key step did I not do? Yeah.
You didn't actually give a value to the instant variable.
Right. I didn't give a value to our 2 instance variables. So I'll change this to be this. Okay. So that's great. So just to, yep, I got enough time to do one method. Has to be an easy one. Let's do add. Actually, I don't want to do add. I want to do something even easier. Let's do toString. Now, here's the things. I want to make it as simple as possible. So I want 3/4 to come out as 3/4. So I want everything to come out in lowest terms. So here are the examples. Now already we're keeping things in lowest terms, and we're keeping the signs are in the right spot, so that's good. So why wouldn't it work to just do this? What if we just do this? Return numerator plus slash plus denominator, if we want to convert our okay, which of these examples up here would it do wrong if we just did it the way I just wrote? Well, 3/4 will work. 6/8 wouldn't be stored as numerator and denominator. It would already be stored as 3/4 because we divided out the GCD. So that would come out as 3/4. Right. This here, 2 divided by 1 would come out as 2 divided by 1. So that's no good. And 0 divided by 8 would come out as 0 divided by 8, and that's no good. So what we need to do is say if, let's see, if the numerator is 0, what should we return? We'll just return the string 0. What about if the denominator is 1? We will return just the numerator. So we say numerator. I got to turn that into a string, so I'll just do this trick of pinning it to the empty string to turn it into a string. And else redo that. Now, we don't have any math yet. We can't add, multiply, and divide, but we can at least we can do a couple things. We can create these things and print them out. So let's see. Let's see what it prints out when we run. What do we expect to see printed out? 5 3/4, right? Yeah, so it's printing them out right. So what remains is to actually come up with the code to add things together. We can create them, we can print them out. We just got to do the stuff in the middle. So we'll pick that up next time. If you had intended to go upstairs to the new pre-major social, now's the time up in MEB 3147.